We're going to round out our lesson on derivatives as a function by talking about higher order derivatives. And then we get to some really interesting stuff in the next section. So basically, we're going to explain the meaning of higher order derivatives. So we've been seeing the derivative, and everything we've been seeing so far is like the first derivative of a function. But it's possible that we have like f double prime means second derivative, third derivative, fourth derivative, and so on of a function, which means we do the process again. And these other derivatives can have other relationships. For example, how velocity is the first derivative of position function, and then the derivative of velocity is acceleration, which makes it the second derivative of position function. So these are all similar notations. They mean the same thing. Second derivative, second derivative, second derivative, third derivative, third derivative, third derivative, fourth through, and so on. So, find a second derivative. F of x equals 2x squared minus 3x plus 1. Find f double prime of x. So, to do this, we first have to find f prime of x. We'll look for the limit as h goes to 0 of f of x plus h minus f of x all over h. So this is going to be the limit. Give myself a little more space here. As h goes to 0 of 2 times x plus h squared minus 3 times x plus h plus 1 minus the quantity 2x squared minus 3x plus 1 all over h. We have the limit as h goes to 0 of 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. And that's going to be the limit as h goes to 0 of 2x squared minus 4xh plus h squared, 2h squared, excuse me, minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. Now we're at the point that things are going to go away. So our 2x squared is going to go away, our 3x is going to go away, our 1 is going to go away. And this leaves us with everything with just an h in it. So we have the limit as h goes to 0 of negative 4xh plus 2h squared minus 3h all over h. And if we divide an h out, we have the limit as h goes to 0 of negative 4x plus 2h minus 3, which will be negative 4x minus 3. So now if we look at the derivative of this, the second derivative of the original function, so this was the first derivative. For a second derivative, that's going to be the limit as h goes to 0 of f prime of x minus h minus f prime of x all over h. So we'll be looking at the limit as h goes to 0 of negative 4 times x minus h minus 3 minus the quantity negative 4x minus 3. I don't think it's a negative 4, is it? That should have been a plus. I picked up a negative along the way. Okay. All over h. And so we end up with the limit as h goes to 0 of 4x minus 4h minus 3 minus 4x plus 3 all over h. And everything without h is going to go away. And we have the limit as h goes to 0 of negative trying to think, should that be negative or positive? I think it was x plus h. Is x plus h. Okay, so plus. So for h, so we have the limit as h goes to 0 of 4, which is 4. And that's our second derivative. So f double prime of x was equal to 4. Okay. That's the process. The example they want you to try, which I kind of used up all the space for, but we'll look at this. F prime of x. I feel like you've already seen this one. The limit as x approaches h of f of x plus h minus f of x all over h. It's going to be the limit. As h goes to 0. Not x goes to h. Of x plus h squared minus x squared over h. So it's going to be x squared plus 2xh plus h squared minus x squared all over h. The x squareds go away. This leaves us with the limit, wrong color, as h goes to 0 of 2xh plus h squared over h. Now everything has an h in it. H is divided out, becomes limit as h goes to 0 of 2x plus h. And as h goes to 0, we have 2x. So we take the second derivative, we'd have f prime of x plus h minus f prime of x all over h. So it's going to be limit as h goes to 0 of 2 times x plus h minus 2x all over h. So we're going to have limit as h goes to 0 of 2x plus 2h minus 2x all over h. What's left is the limit as h goes to 0 of 2h over h, which is limit as h goes to 0 of 2, which is 2. So I don't know if you're starting to see a pattern yet, but the next section we get to look at those patterns of shortcuts. So I want to start off by saying this one had a result of 2, and the original function was f of x equals x squared. Previous one had a second derivative of 4, but it started out as a 2x squared minus 3x plus 1. Okay. Got one more. We're going to find the acceleration if our position function s of t equals t cubed. So that means we're going to find the first derivative, which gives us velocity, and the second derivative is going to give us acceleration. So what the key point to take out of this is that acceleration time t is the second derivative of t, of s of t. So our velocity, if you recall, is going to be the first derivative. And that's going to be our limit as h goes to 0 of s of t plus h minus s of t all over h. So this one's not a pretty expansion, but we're going to do it anyway. Don't have a lot of choice. And we have the limit as h goes to 0. That's going to be a t plus h cubed minus t cubed all over h. And so if you recall, that binomial cubed is going to be t cubed plus 3t squared h plus 3th squared plus plus h cubed minus the t cubed. And then I say the t cubes go away. So we end up with the limit as h goes to 0 of 3t squared h plus 3th squared plus h cubed all over h. And h will divide out of every term. Notice every term has an h. So we have the limit as h goes to 0 of 3t squared plus 3th plus h squared. So I don't know if you noticed yet that if you have a t left over or an h left over after you divide the h's out, well, h is going to 0, so those are all going to go to 0. All we have left is 3t squared. So our acceleration is our velocity derivative, which is the second derivative of the position function. So that's going to be the limit as h goes to 0 of, should I just say, s prime of t plus h minus s prime, gosh, I'm so used to using f, s prime of t all over h. So that's going to give us the limit as h goes to 0 of 3 times t plus h squared minus 3t squared all over h, limit as h goes to 0 of 3 times t squared plus 2th plus h squared minus 3t squared all over h. You distribute the 3, we have the limit as h goes to 0 of 3t squared plus 6th plus 3h squared minus 3t squared all over h. Now, the 3t squareds go away. And what do we have left? Limit as h goes to 0 of 6th plus 3h squared over h. Limit as h goes to 0 of 6t plus 3h. As h goes to 0, it's going to be 6t. And that's it. So I don't know if you see any connection now, and we're going to define it a little more in the next section. But we start off with a t cubed and we're at a 6t. So we went from a t cubed to a 3t squared to a 6t. So, okay, I hope that makes some sense. And that's it for the derivative as a function.